And I realize I'm not sharing my screen. All right, welcome to our second session here of basic model building. Our agenda for today, typically we have 3 parts, but we're just going to start with a part 0 today. We're going to do a quick recap on what we went through last session. I know some people were not able to join last session. We had some conflicts, and so we're going to do a speed look at just some quick introductions and a class syllabus. So I'll have you guys drop just some introductions in the Slack chat, maybe as I'm going through the class syllabus very fast. We'll just give a 10-second look at GitHub and Jupyter Notebooks. And I'll just share the link for the introduction to Python Jupyter Notebook that we went through yesterday. The theme of 2 days ago, the theme of Monday was to just get an introduction to Python and an introduction to the class. And then we looked at assignment 1. So we'll come back to, I'll share the link to that assignment, and we'll come back to assignment 1 at the end of the class and see if maybe we can start using everything that we learned today to do the first part of that second half of the assignment. So, all right, jumping in here, I'm going to jump to the class syllabus. While I do that, if you guys could maybe just drop a quick introduction of yourself in the Slack channel here, just who you are and maybe just a little bit about your background, whatever else you want to say there. And I will grab our syllabus here. 10-second look at the syllabus. I dropped this in the channel. I'll let you read through this more in depth. Few key things to note here. I am assuming sort of a basic knowledge of Python. We are going to spend the first week here, Monday and then today, and the first homework assignment, reestablishing our familiarity with Python. However, I do assume you kind of have a background there. So if there's some gaps to fill, I would recommend maybe spending the first week. You don't need to be an intermediate or a professional programmer in Python by any means, but understanding what are the objects that exist in Python, how do we interact with those, what are the data structures, what's a function, how do I call a function, how do I pass parameters to a function. Those are all the things that we're going to be using throughout this course. The other things to note is I shared a few textbooks that I found interesting through my learning and useful through my learning experience. Everybody learns in a different way. So throughout this course, I'm going to try to share different mediums for you to consume knowledge through. Some of them will be textbooks. Some of them will be YouTube videos, etc. So Introduction to Statistical Learning, this is going to be your resource for everything machine learning and methodology. Think Python if you're looking for something to really introduce you to Python and how that works for the first time. ProGit for interacting with GitHub, and then Python for data analysis if you want some more information on how to manipulate data in Python. So NumPy, Pandas, those packages, that one's really good. Generally, here's our class schedule. So introduction and getting started. Today, we're going to focus on Python and Pandas. Next time, we're going to get really into that data wrangling and data visualizations. And then we're going to be set up for success to just run through a bunch of different algorithms and methodology for the rest of the course. This is just a pass-fail course. So while I do have assignments, because I think they really help solidify concepts and kind of bring in those aha moments and help things click. And there is an exam to just evaluate the assessment of knowledge at the end of the course. They're, of course, broken out into these different increments. And so if you have, your exam completed in assignments and came to every class, you may not even need a final model, or I guess vice versa for the exam. So final model is just, we don't have time at the end of this course to do a whole presentation and building a model and writing a paper on it. So instead, we're going to do the simplest version of that. I'm going to have everybody train a model and create an output file called a job-lib file, which is just a model object. I'm going to send that to me, and I'll just show everybody's models objects together. We're going to build to this progressively, so it should be a pretty quick win for you to get that and then train over different metrics, and then we'll get to see how everybody's models perform. It'll be great. Okay, that's my speed run of the syllabus. This is here. Next, let's jump into, I encourage you to check out everybody's introductions in the Slack channel, but next let's just quick dive into GitHub and Jupyter Notebooks. Let me start with a question. Is everybody able to open up Jupyter Notebooks on their computer?
Yes.
Good.
I was wondering if you have any opinions on VS Code as opposed to Jupyter.
Oh, yes, you can certainly use VS Code. So you are welcome to use a IDE, basically an editor, if you'd like to, instead of writing in Jupyter Code. So let me pull up. I use PyCharm. VS Code is very common as well. I'll pull up PyCharm here real quick.
I use PyCharm with PEP 8. Are you suggesting that we use something like that?
Yeah, you are more than welcome to use anything you want. If you use PyCharm or VS Code, I'd recommend going to their plugins section. PyCharm's not going to let me open it right now. I'll show you guys another time. I have to add my license. I'm not going to mess with that. But in PyCharm or VS Code, you can go to plugins, and in plugins, search for Jupyter. That'll come up. So if you add the Jupyter plugin, it'll be you'll get that notebook interface to it. Yeah, go ahead and use the IDEs. Those are your tools. For those of you who aren't familiar with IDEs, they're basically, instead of using like text, using like a notepad or something like that to write text in, we use word processor, right? Because word processor has a lot of tools for us. It'll automatically make text bigger. It makes our lives a little easier. It's an editor. And so they have those same things for code. So they have Visual Studio Code's a really common one. PyCharm's another common one. And so if you prefer to use an editor, they offer a little more intelligence, like automatically sensing when there might be issues or errors in your code. You can also bake in like Copilot into those if you want to have code that writes code for you, which is pretty cool. So, all right, I'll stop rambling about that. Answer is yes, feel free to use those. And okay, so I don't want to put anybody on the spot, but I want to make sure that everybody's set up well. Should we spend any time making sure, does anybody not have Jupyter Notebooks running on their computer? Do you have any difficulty right now? Let me just show you what that means, by the way. What does Jupyter Notebooks running on your computer mean? So I would hope that, it depends on if you have a PC or a Mac. I'm on a Mac, so I'm going to have a terminal open. But I'd hope that you'd be able to run Jupyter Notebook and just hit enter here. And it would, in wherever your web browser is open, it might open a Jupyter Notebook that would look just like this.
So what you're sharing on your screen is not what we're seeing, or not what we're presenting here.
Am I sharing the wrong screen?
We're seeing agenda.
Yeah.
Oh, thank you. I am sharing a window, not a screen. I appreciate it. I can fix that. Here we are. Thank you. I do prefer to share a window. Let me kill this. Okay. So here's what I meant to type. This is going to open to a specific location that I'm currently located in that directory. But wherever you're located, I'd hope you'd be able to type that out. Type out JUPYTER in the notebook. It's Jupyter with a Y, and then hit enter, and then you might see something like this. And if the window doesn't open automatically, usually it'll just automatically direct you to a browser. If it doesn't, you can always copy these links that are pasted, these URLs that are pasted at the bottom. So you copy that, and you can paste that in. You can open the same thing. So the reason I ask is because we're going to be working through Jupyter Notebooks. We'll do, I think, just actually working through code is the best way to learn in these types of situations. So we're going to be doing that each class. I'll just say, I guess if you have trouble, just reach out to me after class. I'm happy to share my screen, share your screen, walk through that. It's sometimes we can run into issues with packages and stuff like that, versioning. So happy to walk through that. We'll keep moving for today. Oh yeah, let me show you the links. So in the chat, I put a bunch of links that you'll see in this section over here. So the class syllabus, I linked to where I dropped that in the chat. The introduction to Python. This is the lecture that we did yesterday or Monday. I'm going to keep saying yesterday. This is the lecture that we did on Monday. So if you guys want some Python practice, go through this notebook. Here's a breakout exercise notebook if you want to work through some challenges to get your mind churning on how the Python programming language works. I'll drop the answers to these by the end of the week. And then this is the first assignment due February 12th. If you were late to jumping in the class or had a conflict with the other class, February 12th, flexible deadline. Happy to push that to the Wednesday night instead. Don't stress about that too much. We'll come back to this at the end of the class. Okay, so we're going to jump into the rest of this content and section for today. First thing we're going to go through is data structures. And let me open up my we're going to do a brief review of Python and then jump into these data structures. So, and you guys should have these PDFs. All right, so Python foundations for data science. We already talked a little bit about the Python programming language, how it's one of those maybe higher interpretation languages. In programming, there's this thing called Hello World, where in each language, that's like your standard for how to get started with the language. I apologize as I plug in my computer here. I did remember my charger this time. It's a bit of a debacle last time. Oh, we lost the... Try not to step on that cord. It's kind of finicky. So in Python in every programming language, there's this hello world, which is what is the syntax to print the actual words hello world, typically followed by an exclamation point, to the terminal or to the console. And so in some languages, there's quite a bit of ceremony around that. In Python, I think this speaks to how simple the language is. It's just print hello world, and you'll need these. You'll find that this is the function that we're calling when we get to talk about functions later today. Print is actually a function. And so this is the function. We're calling the function print. And these curly brackets, and not curly brackets, rounded brackets. What's the word for these? Parentheses, thank you. These parentheses are what you're going to pass parameters to your functions. You're good. So we're going to pass parameters to our function. In this case, we're passing one parameter, and we're passing the parameter a string. And we know it's a string because it's got two quotes here and two quotes here. So a starting of a string and then an ending of a string. And then everything in the middle is what's contained inside that string. So in the first position, we have a capital H. In the second position, we have a lowercase e, and it does it one character at a time. So each of these are a character of a string. A space is a character, a comma is a character, exclamation point's a character. And all of these things make up the string. So if you run length on the string, it'll actually count the number of characters and add that up.
Do you need double quotes or can you use single quotes?
That is a good question. So in some languages are really strict about what double quotes mean versus single quotes, string literals. Python is much more hand wavy about that. So they're used typically interchangeably in Python language. I have not run into an issue where single quotes versus double quotes have mattered yet. I'm not going to say that doesn't exist, but I haven't run into that issue. So they use them both ways. That's a good question, though. Some programming languages definitely have that. They can be very different. So Python's really important for data science. It's really simple. It's really readable, but really the strength comes out of these packages. So when we look at like Pandas, NumPy, sklearn, or otherwise called scikit-learn, you'll hear it both ways. That's really the strength that Python lends to this knowledge. I'll share with you guys a video. A lot of people, there used to be a big debate in the field of machine learning. Do we use R? Do we use Python? And it used to be such a big thing that when I built my MLOps platform at work, I actually made us language agnostic, which meant that you could deploy either a model in R or in Python, and it worked. And this was a really important thing. These days, we've moved further away from that, and now Python has very much came and stood out as the predominant language there. R is still used in statistical analysis, so if you look into academia, if you're going to do research, it's still used in that domain, but in the career field, it's really just Python these days. R has we never deployed a single R model when I built that platform, by the way. They were all in Python, which I thought was funny. Okay, so in Python, variables are dynamically typed, which means you don't have to declare. So in some other languages, Java and many other things, you'll have to say y equals int 10 or float. You'll have to say what type this is. Python just kind of gets it. It's like, I understand what you're trying to do here. I can probably figure that out. So that sometimes causes problems, but it does make our lives easier. Basic arithmetic, we went through this. It looks just like it looks. So this is a variable, and we're creating a variable. We're calling it the word sum. And this is something called our assignment operator. We're assigning whatever is inside x plus whatever is inside y to the variable sum. Now, these are just naming conventions. X can be a string. It can say, I am a string. And y can be, yes, you are a string. And we can add those two strings together. And then the word sum could be, I am a string, yes, you are a string. So it doesn't, just the naming of the variables, we try to make them logical, but that there's nothing that enforces that. So I guess here it's showing that you can add strings. Conditional statements, so we talked about this. If x is less than y, then print x is less than y. In Python, indentation is very important. So a lot of other languages, you can do crazy stuff, put everything on one line and just use curly braces for all your if statements. You can't do that in Python. Well, you can't do it in this way. So when we're trying to evaluate x is less than y, you guys are going to say that's not true when we get to lambda statements, but so that's why I caveated that. But if x is less than y, by the way, these if statements, I didn't mention this yesterday and I realized I should have, need to be followed by a colon here. That tells you I'm done evaluating conditionals. So the structure of these statements goes your if or your elif or your else, and then the conditionals you want to evaluate. What are the things that you want to compare? Because you can have more than x is less than y. If x is less than y and x is less than z and x is less than, you can go on for a long time. So then you have your conditionals. When you're done doing that, you put this colon here, and then on the next line, you have to indent. You use a tab or 4 spaces typically. Of course, you can change this in your IDE, but typically 1 tab or 4 spaces. And then this has other structures. So it has if, elif, else. So when we talk about control flow, which means where the computer is in the processing, with if, elif, and else, when we get into this if x is less than y, if this is true, if x is less than y, it will print this and it will not go through any of the evaluations of these other situations. So it like exits at this point. These are kind of off ramps for it to stop doing processing. So that's an interesting thing to keep in mind. Yeah,
If we
please.
were doing like an if with an or condition, the semicolons or whatever colons would be outside the or, is that?
Oh,
correct?
that's a good question.
So it's
Yeah.
not like just one condition?
You bring up another thing I should probably mention too. So let's just open a new. Let me make sure I know what you're saying. If one is less than two, you're saying would it be outside
Or inside?
or inside?
Yeah.
Okay. 2 is less than 3. Okay. By the way, in some languages you'll have to do then. You don't have to do that in Python. You just do your stuff. It gets it. Print 1 is less than 2, or 2 is less than 3. Okay. The or would be on the inside,
Okay.
but you bring up a really good point, which is order of operations sometimes really can get you sometimes. So the way that
It would stop at the first one is.
yeah, so it'll do 1 is less than 2, and then the or statement, and then 2 is less than 3. And then if either of these are true, then it evaluates here. But sometimes sometimes people like to put in parentheses in here just to show that you're not evaluating if it's 2 or 2. Does that make sense? Yeah, so sometimes it's not so hard in this situation. I came up with a bad example, but there are ones where it gets sticky. And so sometimes when you have like a lot of logical conditions, people like to put parentheses here. You can see that makes readability a little more readable, and it kind of enforces a structure, and there's not something funky going in where it's evaluating in the middle or something that you don't expect to happen. Good question. Also, generally, you guys just pause me, just like she's doing. Remind me your name again. Missy. Just like Missy is doing, pause me. I tend to just ramble. So we have loops. We have here we've called out for loops and while loops. For I in range 5. Range is a function, by the way, that's used a lot in Python. That just means create a set of numbers from 0 to 5. There's a lot of things to be aware of on a loop that I'm not calling out here. So let's just do that in here. For I in range 5. Well, first let's first look what range 5 is. Range is a function, and what does it do? Well, sorry, it's a generator, so it's not going to print it. You have to give it something to force it to print that. So I wrapped it in a list. We won't get into generators, but I wrapped it in a list that forces it to actually print out the values of that. So we have 0, 1, 2, 3, 4. So notice that because Python is 0 indexed, it created a list of 5 numbers, but it didn't create up to the number 5. So when you say range, it's going to create up to the number before it, but it starts at 0. It's because Python's a 0-based language. Everything starts at 0 instead of 1. So we can do print I. So the for loop will go through each of these, but like I said, we'll only print to 4. Okay, that was the main point I wanted to make there. Example of, and then while loops will basically continue until the condition is met or until you tell it to exit. So a very common way to use while loops can be dangerous because you can be stuck in them forever. So we can do while true, right? We'll just do print 1. Here we go. You're going to see this little asterisk here, and that means this cell is still running, and I can't run any other cells until this cell finishes. Well, it's going to run forever. So if you actually look at this list, you can't tell, but it's infinitely getting bigger and bigger. You can see my little scroll bar is moving up here because this list is continuing to print, and it will continue to run till it eats all my RAM. So we're going to stop that. A common structure that some people do is while true, like do something. In other languages, this might be called the do while loop. And then after you meet a certain condition, a lot of people will tell it to break, which means it will just stop. So this is only going to print one once. So that's one way of using it. You can do like if 5 or my var equals 5, then break. So what we're going to do is we're going to make, I'll show you guys something interesting, a little thing you might see. We're going to make a var called my var equals 1, my var plus equals. Oh no, that will run. I was trying to get it to throw a variable is not recognized error, but oh well. So you're going to want to create this variable outside of the loop or it won't recognize it. And I didn't show you anything. It ran, I just didn't print anything. There we are. So we started at 1 and then we added 1 right away and then it printed. So we started at 1 while true, so it's going to continue to run. I said add 1 to my var, so it printed 2 because then we put the print state after the add 1 and then it came back into the while loop and it said, oh, add 1, print this, so it printed 3, oh, add 1, and continued to do that until we hit 5. So it added 1, it printed 5, and then if it equals 5, then we break and it just stops the loop. So sometimes you'll see that type of logic. If condition is met, break the loop. All right, that's enough
Can you
for,
just go one
Yeah.
second?
Yeah.
Where you were at, just trying.
oh, back in the notebook?
Yeah.
So sorry.
Make sure that's right.
Yeah, and let me just drop this in the chat. Happy to. Hold on, figure out where my mouse went. So fun fact, I'll teach you guys a trick here in Slack. If you hit tick, 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 which is in the upper left-hand corner on a Mac, and then you hit enter, it will paste your code in something called a code block. Oftentimes you're going to want to do that because you might run into issues. See, I don't have any in here. But basically, if you look at the way quotes like these, see how these are straight? They're just like straight up and down. Well, if you look at quotes, I don't know if I have any in this document.
Right now.
Here, yes. Well, those are in the code section. But do you see this comma here? Do you see how it has a curve to it? Basically, under the hood, that causes problems. Not the way it looks, but the way it's represented in the underlying ASCII language and the underlying text, that will cause problems. So if you just paste your code into text and then you try to run it, you're getting some issues. Try maybe pasting it into a text editor or try replacing the quotes if you're running into that issue. Okay, a little nugget of knowledge there. All right. It'll save you many heartaches, I promise. All right, data structures. So today we want to talk about data structures. You can quite literally have an entire class, a whole college semester on data structures. So I won't be able to give you guys what you really deserve out of this, but there are a couple of ones to note of very, very high importance in Python. One is a list, and everything in Python is an object. And we're going to get into maybe just a light touch on object-oriented programming, though I don't want to dive too much into it because it's a complex topic, but everything's an object, so that in Python, you can make things a list. So you can convert things to lists, and lists will have functions. And in Python, they're represented these lists are by these square brackets. So if you wrap something in parentheses, I don't know why I'm struggling with that today. If you wrap something in parentheses, that's not a list anymore, even though to our eyes it might look like a list. A list is a physical object, has a strong definition with it. So it has these brackets. You can convert things to lists by running, in here I ran I called this is called casting. I created this as a list, so you can have something that starts out as not a list. So this is not a list equals 1, 2, 3. That is not a list. How do we know that's not a list? It's because I can run type. That's a tuple. And so if we want to make that tuple a list, we can do something called casting. We can convert it from one type to another. So we can make this not a list. That's now a list. And we know it's a list because we can run, well, it looks like a list, it has square brackets. But we can verify that by running type on it. And now it tells us it's a list. You will probably use this type function a lot. It's just type and then you pass anything to it. All right, so lists, you can index into them and they can be changed. That's the big thing to note, I guess, about lists. If there's one thing I was going to tell you to know, is that they're mutable. So I can change fruits at 1 equals blueberry, and then if you tried to access this again, instead of saying apple, it would say blueberry. So they're mutable. They also have functions. Append means add something to the end.
It's always the end.
It's always the end. That's a good question. And I have a more useful document. I shouldn't say more useful. I have a more in-depth document.
Question for you. So you
Yeah.
mentioned that I can go by zeros, but then you put group 1 as blueberry, so they're gonna say blueberry, banana, cherry, but how would you?
Oh, you're right. Sorry, I misspoke. You got me. You got me. You get a point. You get a point. 10 points for Gryffindor. Fruit 1 equals blueberry. If you look here in the output, you'll actually see that is in the second position. I misspoke. Python is 0 index, so I can tell you're paying attention. That is absolutely true. So it would replace banana and not blueberry. So out here in the output, it goes apple, blueberry, cherry, and then because we called append orange, it appended orange to the end of this. All right. Tuples. So they're really similar to lists. They look just like them, and in many ways they operate just like them. They have append functions and all that jazz. But you can't, they're immutable. So you can't index and change values within them. And there are situations when that's valuable. There are times when you don't want that to happen. Dictionaries. This is a pretty common structure. So if there were 2 structures I'd tell you to get really familiar with, it's just lists and dictionaries. Sets and tuples, they're a little more nuanced. So dictionaries are used a lot. They're key value pairs. So you can think of this as the key and this is the value. So let me put this in my notebook so we can actually do something useful with it. Here we go. And the values don't have to match up. You can see that this is a string and this is a number. So you have to go number to number, string to string. It can be anything to any data type to any data type. We can get really complicated with it, but let's just start with this. Car.keys, if you call it car.keys, there's some really cool functions that come along with this. It'll just tell me all the keys. So brand, model, year, so you can just get that. And we can do car.values. And it'll tell me all the values, which is useful. And then there's a bunch of other functions. You can iterate over everything in here. You can get really complicated with these, which you'll often see is this. It'll be a dictionary, and then one of the values can be a dictionary. So that's the thing with objects is they can go into other places. So the brand, let's do let me think of something with cars. Seat, seat type, and maybe if it's a leather seat, they want to know like what types of. We're getting really far out of my knowledge domain here. What types of leather it is? Maybe it's. I'm just going to put type. There you go. Somebody said bonding. Bonded. Sorry, you can tell. Very far out of my knowledge domain here. Or maybe if it's, I don't know what's another seat type, cloth. They want to know it. Is it polyester. I don't know. It's probably not a thing, but you can see how this can have like nested. What did I do here? I forget a comma. There we go. You can see how this can actually get something called a nested dictionary. We have dictionaries inside of dictionaries inside of dictionaries, so you can get complex. But
So when you run like the keys on that, what is
let's do it.
Okay.
Boom.
Okay.
So we have seat type.
This.
Seat type, because the keys didn't change, but the values. There we are. So when you run values, it gives me the whole thing.
Interesting.
So this may come up again as we're working through certain packages. Okay, let me.
Can you go back? I'm
Yeah,
sorry.
absolutely. No, don't be.
I'll take a picture.
Yeah, please do.
No, yeah.
Perfect. And happy to share this afterwards too. Well, I'll call this. Oh, sorry, that's probably right in the middle of your picture. Sorry, go ahead. Okay, I'll call this February 7th in class examples. There we go. All right, let's see. We are, okay, so data structures, we're doing well. We're gonna take a break here shortly. I may take some of our function and library time to dive more into data structures, and that's okay because I want to show you guys this page, which I had already had open. There we go. So this is actually the Python documentation. One of my goals for this course is to get you guys really familiar with reading documentation. I just want to get you used to the syntax, the way the information is laid out, the way it's represented, so you can yourself go to the documentation and learn stuff, because that's pretty much how most machine learning works. Is you just go to the documentation, you try to read it. You know, you can check out other tutorials and stuff, but the documentation is going to be the place that's going to give you all the information about the nuanced ways that you would want to use it. So this is actually the Python documentation. Python's a open source programming language, so many really smart people across the internet, the knowledge of the many, have created this language, and so this is all the documentation that exists with it. So as we look at lists and you want to know, what can I do to a list? You can, these are the functions. So list, this is representing the objects. So this, if you're trying to use this, you're trying to use the append function, you wouldn't type the word list.append. Here, I'll copy this. What you would actually do is, where did our list go? I'm gonna make a new list. If this is my new list, here is a list. This is my new list. You wouldn't call list.append. Also, it's going to give me an error. You would call whatever the name of your list is, whether it's my new list, and you can append this. We have to print that. Well, now it appended it twice because I ran it twice. So you can see if I ran it 3 times, it's going to continue to append that because we're storing this in memory. That's something I should note. This function is in place. It doesn't say that in here, but this function is something called in place. In a lot of Python, you're going to have to assign things back to a value. So you'll have to make a change to something. You'll have to do, I'll show you something that is not in place. So if I did plus new this, sorry, it's going to, I'm just going to have to do it this way. actually. This will make more sense. Yeah, it's gonna want me to. Okay, you can't just add. So this is a good example. So you can't just add a string to a list. Like that doesn't make sense. Python doesn't really know what to do with like all of this plus this string. It doesn't understand that I'm trying to put the string as a member of the list, which is typically why that append function works. But we might be able to, let's see how long this list is. So index out of range. So this is another interesting thing. This is why the append function exists. So I'm trying to show you something which they've already built a function in for it. So notice that this is zero base. So it goes 0, 1, 2, 3, 4, 5, 6, 7, all the way up to 8. When you call length on it, it tells you there's 9 elements in here. So you know your length is always going to be 1 longer than your index number because of that zero base. And so if we try to say my new list at 9, which 9 would be a position that doesn't exist in here. Remember, this goes 0 through 8. So if we try to say my new list at 9, equals, it's going to say list assignment index out of range. So basically you can only modify to the indexes that exist here. If you want to add an entirely new index to a list, you have to do the append function. Okay. Anyways, all I was trying to say is that's in place, which means it modifies it immediately. Just like if I ran this again, it would modify it again. What I don't have to do, what I mean by in place, is I don't have to do this. My new list equals my new list dot append. You don't have to do that. You can just, my new list, it's in place. Okay, well, that'll come up again later. Anyways, there's a bunch of other things. There's extend, which does something slightly different than append. There's slightly different operations. There's insert, there's remove, pop. Pop removes the last thing in the list. That's a common programming data structure, popping something off of a queue. So in this case, a list. So there's a bunch of different functions. We will not get into copying. So I would encourage you to check these out. Ignore the stacks and queues stuff, I guess. Just this, more on lists is knowing these functions might be useful. List comprehensions can be useful. These are like sophisticated for loops. So remember when I said you can't do things in one line on for loops? This is where that's actually not technically true. So this is, they're giving an example here, squares, for x in range 10. So for 0 through 10, take x and square it, and then add that to our list, which is empty at first, but each time we run, we're going to add that value. So squares dot append. And at the end, you get a list of squares, 0, 1, 4, 9, 6, etc. This is something called a lambda function, which is, I would label this maybe intermediate Python. So this is a little more complicated. But basically, if you set up the syntax, list map lambda x, and this x is just, this x here is just a variable, then you can do an operation on that variable. And so this is the same code as this up above. It's just one line. I don't know. People think it's cool sometimes. Sometimes it can be unreadable, and it's just better to write it as a for loop. So delete statements. More about tuples. So if you want to read about tuples, I would read this section here. And then again, sets. And then dictionaries, again, lists and dictionaries. I'd say maybe just focus on lists, the first section on lists, and then this section on dictionaries. It's going to give you a lot more useful information than I might here. Some looping techniques to loop over dictionaries. Sometimes that's useful. I won't get into that.
Is there a limitation on how much of the, or how many items you can put in a dictionary? Like, is it capped? Or if it does, I mean, it's so long or storage.
I think theoretically you might run out of memory on your computer, but it's going to be quite a bit.
Okay.
It's going to be like, I don't even want to guess, but I'm guessing like millions in my head.
Oh, okay.
Yeah, it's going to be pretty big. But eventually you would run out of memory. But they can get pretty deep.
But then you could use probably a different type of.
Yeah, so then you
Right.
just think about how do you do it differently? Yeah. Okay, I think we're going to take a 10-minute break here. We'll come back at 7:55 Central, if that works for you guys.
That's an hour.
Lovely.
Oh my gosh, don't come back at 7:55 Central. 7:05. I apologize. You can tell I need to drink more of my coffee here. 7:05 Central. All right, we'll see you all shortly.
Thanks.
not dig a hole off yourself, like, right? You have an exam right over there.
I just realized you guys were looking at like half of my face the whole time. That's great.
Just the forehead.
Just my forehead. All right, we're gonna dive back in here. I have one little takeaway, and I linked this. It's one of those million links that I dropped, but if you want some practice with Python data structures, this website's usually not too bad. They have a lot of really annoying ads on the side and try to prompt you to log in all the time, but you don't have to do that. They have these exercises in here, so you can try to run these on your computer. It talks about what a list is. They give kind of this visual representation. Remember I said that Python, you could do negative indexing. But notice when you go from the negative side that there's no zero, right? It just starts at -1. So this is kind of a visual implementation. When you take portions of a list, so when you go from position 3 to position 8, that's something called slicing. You'll hear that a lot. So let me see if they have an example in here. They don't have a slice in here, but maybe a little later they do. But you'll hear that terminology, slicing a list. So that's taking from K to like R here, taking something out of the middle. And it's this, I'll just do one because it's, all right. So if we count equals 1, 2, 3, 4, 5, and we want to slice count, you can do this syntax where we can say we want everything from position 1 to position 3. What do you think this is going to return? What numbers?
1, 3, 1, 2. Just 1, 3, because you're not.
2 to 4.
All right, we have 1 to 3, we have 2 and 3, and we have 2 to 4. Let's see.
2, yeah.
We got 2 and 3. So with Python, this third number, remember it's 0 index, so it's going to go 0, 1. So we're going to start here at the 2. The reason it doesn't go all the way up to the 3 is it actually stops the number before that. So it's really confusing. But when you slice, if whatever number you say to go up to, it actually stops at the index right before that. So it's not inclusive of that. If you remember from SQL, that's terminology from SQL, not inclusive of the third, up to 3, not including 3, or up to the third number, not including the third number. So 0, 1, 2, so it'll stop here. So anyways, all I was trying to say is these are good things. You can try to play around with these. Let's see if they have any. So then they have dictionaries in here, examples of what you can do with dictionaries, creating ones, how to get elements out of a dictionary. If you want to, that's one of the cool functions of dictionaries I didn't mention, is you can call this get function. If you have a dictionary, it's got a bunch of different keys and values, you just say get, and you pass a key, and it finds the value associated with that key, which is neat and really useful. And tuples, we don't need to worry too much about those, but they have some visual representations here if those are useful to you. So feel free to try out. I've got a lot of exercises on here. You can try these out yourself. Again, I linked that. What we're going to jump to now, again, apologize for my messy repo. No logical structure here. I put things in random places, but here is the object-oriented. I'll just drop that again in the Slack chat. I linked this, but this is what we're going to go through. We're going to go through functions. So I made this for a object-oriented programming teaching session that I did. And so we're probably not going to do the second half of this and talk about objects. We can talk about it briefly, but the main goal here is to talk about functions, and maybe I might touch on classes, but I just want you to take away functions. Don't worry too much about classes. So just to talk about what object-oriented programming is, and you may hear two different paradigms. One is object-oriented programming, or OP, or OOPS. Some people call it OOPS. I think that's hilarious. And it means to program in a way where objects are actually represented as things of the world. So if I want to make a cat, instead of making a variable called cat, I might make an object called cat, and then it might have attributes about it. It might have color. What color is the cat? Weight. What's the weight of the cat? And the point behind objects is that everything that's a cat has to look the same. All cats have to have a color. All cats have to have a weight. And then maybe cats might be able to do things. Maybe cats can meow, and maybe their meows can have different pitches. So, but no matter what cat you are, you have to be able to meow. If you can't meow, you're not a cat. And so that's what objects do, is they enforce structure. And you guys have already worked with objects. A list is an object. So when you create a list, all of those things that we talked about in this data structure, these are actually functions of a list. All lists need to be able to pop. If you can't pop, you're not a list. They need to be able to remove. Now Python does all that for you. They build the object. You don't have to build the object. You're just creating the object from their template. But that's the power of an object-oriented programming, is you create these templates, and then anybody can make anything that's that object. This will be, you don't need to know object-oriented programming. We're just going to do a different paradigm, which is called functional programming. A lot of people sometimes call this scripting. You might hear referred to as scripting. Basically, it means we run our code in one notebook or in one Python file, and we run it from top to bottom. And the functions are going to execute in a logical order. They're just going to go top to bottom. Object-oriented programming, sometimes you'll have files over here and files over here, and they'll read in and do different things. Too much for this class. So we're just functional programming. It's really simple, and there's a lot of really great things about functional programming. It's very interpretable and logical and easy to debug. So we're going to talk a lot about functions, which are the heart of functional programming. And yes, I think that's everything. Okay. So here's functions. And I apologize because I gave you guys the assignment and you're probably like, what is all this code? I promise now we're getting to functions. What is all these parentheses and brackets and what the heck is a def? So functions are defined with the keyword def. Remember that Python has keywords, so they're reserved words. You can't call a variable def, for example. They're reserved and they do specific things in Python. And so def is what creates a function. It means, I believe it means defines. Oh yeah, defines here. So it defines the function. We'll talk about execution here in a second. So def defines the function. So if I made something up here and I said, say hello function, this is not a function. Well, let me print that because that's also not going to do anything. This is not a function, and it's going to actually yell at me and say that's invalid syntax because I don't know what I'm supposed to do with this. And the reason we can't define functions this way is because this is how we call functions. So we can't call functions in the same way that we define them. Defining a function means you're creating it. You are laying out the logic for how it's going to execute. You are you're putting your recipe together. I'm trying to think of a good example for defining versus calling. But calling is when you're ready to use that. And now you're like, okay, now I actually want to use that. I want that to actually run. That's when you call a function. So this is called calling a function. And the way that you do it is you say the function name, and then you pass 2 parentheses afterwards. And inside those parentheses is where you pass parameters. We'll get to parameters here in a second. But this is how you call a function. So we can, I tried to do something funky up here, so it's going too long. There we are. So notice that it said, say hello function is not defined, because I can't call a function without building it first. So even though it was written in the code, I never ran the cell. So even if it's written in the code, you haven't passed that code to the interpreter underneath. So you have to pass the code to the interpreter. Otherwise, how is it supposed to know what to run? So this is how you build it, and then this is how you run it. What?
What did you call it? You said you didn't want to.
Oh, the cell, CELL,
Cell, okay.
cell. Yeah, so one of these is typically called a cell. Yeah, apologize, I'm a little hyped up on caffeine. So I'm gonna break a few things here just to show you how things will break. This does not work because you have to have at least one thing in your function. Or if I did my equals one thing, this will work. But actually, if I run this code here, notice that it doesn't say hello because this print statement is on the outside of that function. So it's not actually in my function. It's in the cell, but it's not in the function. Cells and functions are not the same thing. So now it's in my function. We know that because it's lined up with my other code. So if we run this, there we go. Now it says hello. You can call your function whatever you want. It doesn't, well, within the bounds of Python naming conventions, but you can call it this if you want. Please try to name things logically. It makes everybody's lives easier, but I mean, technically it can be called whatever you want. So this section here, this in blue here, is just highlighted for the name. Again, whatever you want it to be. These are required. You have to have these prints. I believe they're required. There we are. Yep. You have to have those. I'd never questioned if those were required or not before.
Or do they do exactly?
That's an excellent question. We're going to get to that down here.
Okay.
And I'm just going to say one more thing, which is you do need this colon here that says, I'm done creating my name and parameters for my function. Now I'm ready to create my logic here. So you do need the colon. So again, this is the structure. All right, so to your question, Missy, I'm getting better with names. Missy said, what are these parentheses for? Well, we're going to pass something called parameters to this function. So this basically says, I need something called a name. I need something called a name, and then you can use it in your function. So I can say print hello plus name. Now, I didn't tell you what this name had to be. However, in many programming languages, you have to. Python allows you the flexibility to not define that. However, they give you the functionality to define that. So if I want to enforce that, I can say that this has to be a string, str. Or I can say that this has to be an int. This is more like Java-esque conventions to do it that way. But you don't have to. You can just say that it's a name and it's a variable name. Notice we don't know what this is. We haven't assigned anything to this. All we're saying is some type of name, and we're going to use it throughout here. This is where it's actually getting assigned. So under the hood, what's actually happening is we're running this say hello function, and we're creating a new string, and we're calling this string Emily, and then in say hello function, it says, okay, time to call a function. I'm going to call this say hello function. And to the first parameter, I'm going to pass this value. So basically what's happening is name is equaling Emily but we're seeing it happen just in the code. It's happened without us explicitly defining it. Well, the way we're defining it is we're passing it as a parameter, and then it's going to print that. So that, boom. If I don't get into local or global variables, remind me, but I'm going to keep going here. So functions can accept parameters in the definition of the function. So this is called a function definition. We're defining with def of there. And this is called a parameter. So this is called a function parameter. So in dat type, if we're saying if temp is greater than 80 or equal to 85, it's hot. Between 75 and 85, it's pretty warm. Between 50 and 75, it's pretty cool. Otherwise, it may be cold. So we're deciding the temperature. And then we have this other function. We're creating another function called show the weather. And we're passing it day, but we're also passing it temperature. And then inside this function here, it's actually calling day temp. So functions can call other functions, and that's kind of the magic of programming. So this is another function in here, and it's passing temp. So when we call show weather, and if you're ever going to use code in other code, it has to be before. So I can't put day type after show the weather. I have to put it before show the weather. So if we show the weather and we pass Thursday 75, Thursday's weather pretty warm because it's 75, and it's between those buckets of pretty warm. So what's happening in here is it's show the weather. It's saying, okay, call this function, show the weather. So the control flow goes up here to show the weather, and it says, all right, day is equal to Thursday, temp is equal to 75. Now print day weather. Remember, day was equal to Thursday, because in Python, order matters when calling a function. So I just passed values here, Thursday, 75. I didn't say, but another way you could do it, if you really want to be explicit and not have any mistake in the order in which you're passing something, you can name the actual variables you're passing this to. So for parameter day, I'm passing Thursday. For parameter temp, I'm assigning that to 75. But Python will naturally just pick up order. So as you see documentation and code online, you'll often just see people run functions like this. Just know that order matters here. So if I put 75 comma Thursday, that's probably going to have probably going to get a make it break, would be my guess, because we can't, Thursday's a string and it can't equate a string to a number here. Yep, so less than or equal is not supported between instances of string and int. And it actually tells you where it got. So it went to show weather. So it went to show weather and it passed 75 and Thursday. And then it got to this print statement, daytime, this here. It got to this line here. So that means it actually got into our function up here. So it got all the way up to here. And this is what control flow is, what lines of code are executing. And then when we got to if temp is greater than or equal to 85, then it threw the error. So this is the line, you can tell by this little error here. This is the line where it threw the error, and it threw that error because we passed a string to our temp variable, which then got passed to this temp variable. And now it doesn't know how Thursday can be greater than or equal to 85. It doesn't know what to do with that. It's a string and a number. So equality between those two things does not work. Okay. All right. That's probably a lot of information for you guys there. So functions must be, again, I'm probably telling you, I should stick to what I planned to say here because otherwise I throw a lot of information at you at once. But here's where I'm supposed to be telling you that functions must be defined before they can be called. So this is going to break. If I want to try to use my new function, but I'm defining it down here, it's just broken because my new function is not defined. We can fix this by moving this below the definition of the function. Now we can do new things. Oh, generally, it's best practice to define all your functions at the top of a code file in Python. That's Python best practices. Other programming languages, I know Java has a different way of doing things, but in Python, typically all of your functions exist at the top and then your logic at the bottom. So you'll see that a lot. People put all their functions at the top. Parameters must be passed to the function if set up in the declaration. Oh, yes. If I declared, so in the declaration, in the definition of the function, if I said you need to pass me a name, generally speaking, there are other edge case scenarios, but we won't get into those. Generally speaking, you have to pass that. So my function passes Dave here, but what if I wanted to call my function without calling Dave? And we tried to run that, we get an error. My function is missing one positional argument, name. So if you see this when you're trying to run sklearn packages or other packages, just know that you're probably missing a parameter that the function needs to have to run. So this needs name to run. So I have to pass something. I can't just pass nothing inside this parenthesis. In probably all programming languages, many programming languages at least, functions have something called a return value. And what's really cool about Python, you guys have just heard me probably say that about 50 million times. What's really cool about Python, I'm geeking out over here. You don't have to put a return value. So notice in all of these functions, we never had something that said return this when the function's done. But you can have a return value in Python. You don't need to. A lot of times in other languages, you'll have to say like return void or return null to tell it not to return anything. But that's the default in Python, is it returns void, it won't return anything. But you can have a return value. So def multiplied by 3, it takes a number and it returns this number times 3. And that means that calling this function actually returns a value. It returns something. So if we call this multiply by 3 and we pass 4, so we want to call multiply by 3 and pass 4. We want to know what 3 times 4 is. You can see it'll output 12. But it does more than just output 12. It actually returns that. And what that means is I can create a variable called my return value is equal to multiply by 3, and I can pass 4. And my return value is, if I print that out here, you can see that it's actually 12. So I can actually store the return of a function into another variable. So I can store the return of this into another variable. Now, like I said, you don't actually have to return anything, so I'm just going to edit this one for an example. What if this multiplied by 3 but didn't return anything, and we still ran this code? What would that do? Well, let me just print this, because it's not going to print it because it's none, unless let me see what print does. Here we go, none. So remember we talked about none is the null value for Python. So its default is to return none. So if you try to assign that value back, it will quite literally return none. Okay. I think that's all good now. Fix that, good deal. And you can actually do things with it. You can either return it to a value or you can work with it directly. Essentially, this now represents the number 12. After I run this code in Python, this will represent 12. So I can add 12 to 12, and I can get 24. So you can do, and I can change this, number so it represents a different number. I can put this as 15, and now we get 57. So kind of cool. Why the heck do we have these things? Why do we even use functions? Why don't we just do everything by hand? Well, they reduce redundancy, and they're really easy to reuse is the power of them. So if I want to multiply by 3, but I had to multiply by 3 manually every single time, and I was doing it in 10 different places in my code, and then I realized, oh man, I really want to change this to multiply by 3 and add 4. Well, I'd have to go do that 12 places in my code, and I'm a human, so I'm probably going to make a mistake, and then my code's going to break, and then it's harder to debug. Or anytime, my rule of thumb is anytime that I'm using a piece of code that's 3 lines or more, and I'm using it more than twice, I need a function. So 3 lines of code or more, and I'm using it more than 2 times, you should probably just make a function. It's going to make your life easier. Every time you want to change something, you're just going to be able to pass it to the function, and it'll just change that. So the difference is, in that example, we had things in 12 places. If we put that in a function, and then we called it just in those 12 places, we would only ever actually have to change the code in one location. We just change it in the function, and it would just work across all the other code as long as we were calling it correctly. So it really is nice. It's kind of a pain to get started, but after you get using them, they're super nice. It reduces human error, like I just talked about. It's easier for debugging, and then it's easier for refactoring. So refactoring is a computer science term that just means I had old code, I need to make a bunch of changes to it to make it meet these new standards, and that's refactoring. So it makes all of this easier. I want to touch on scope here. So there's something in programming called scope, and And that means how far do my variables reach in my code? When we think about control flow, what knowledge of other variables does the program have at certain points of time as it's running through the code? So I guess here I put it here. It refers to the level of information that the program has access to. So global variables, and this is knowledge that is universal in programming. So it's not just Python specific. Global variables are anywhere in the program. So no matter where I'm at, if it's a global variable, I can call it anywhere in the script. This is a global variable. My global variable equals I'm learning Python variable scope. Variables that are global, they're defined outside of a function. Again, generally, usually. Sort of like, you guys ever take chemistry? Sort of like chemistry, they teach you all the rules of chemistry in your first year of chemistry, and then you go into the second year of chemistry and they say, forget all those rules. Here's all the nuances and the way those rules don't work. So occasionally I'll put generally here. I'm teaching you general rules, but you could definitely prove me wrong. So in this instance, this is a global variable, my global variable, and I called this function test global variable. And I said print my global variable. And notice that I didn't define this within the function. I didn't pass it as a parameter here, but it still can print my global variable. It prints I'm learning Python, because even though this is a function, because we define this variable outside of the function, it has access to that information. Now here's a different example. We can also access this variable outside the function. So we can access it in the function, out of the function, anywhere. Variables that are defined inside the function can only be accessed by the function. So don't let this trip you up. These are called local variables. And so if we call this test my local variable, we create a new variable inside the function called can you access this? Then we're outside the function now. Remember, we're back here. This is in the function, this is out of the function. So we're out of the function now, and we try to call my local variable. It's gonna say, well, it's not defined because we're a part of a code that doesn't have access to that. Now, if we call this in the function, sure, yeah, it has access to that. And I'm not actually calling the function itself, so it's not printing anything, but I can do that here. Test local. By the way, in Python, in Jupyter, if you start typing out your variable name here, test underscore, or your function name, and you hit the tab button, look at that, it'll give you some options. You don't have to type them all out. So local variable, so enter. Oh, sure. So the reason it did this is because I'm giving it the name of the function, but I'm not technically calling the function because I didn't put the parentheses. We got to put those parentheses. And also, I'm not actually printing this in the function, so it won't actually do that unless I print it. What I'm trying to get it to do. There we are. So I'm just saying that for local variables, if they're defined in the function, the whole point is we do not have access to them outside of that function. There we go. So that they're only available in this scope. Okay, ignore these optional resources. That's for something else. But there's some practices here if you're interested. If you really like this, you found this riveting. I'm sure that's not the case. But if you are, you can explore pass by reference, pass by value, keyword arguments, and recursion. I would label those as very not necessary, but maybe more advanced concepts. Let's see, 7:30. Let me just check our schedule here. I want to leave 20 minutes for our breakout activity. I said I would touch on classes. If there's anything you forget today, just forget this. Again, not important. I want to give you a taste, so maybe you have like something to map it to in your head, or if you hear it mentioned in stuff that you're looking through, you know what it is. But functions, remember that. This maybe not so much. So classes are objects. I must have had in the back of my head, I didn't look at this before I started today. I've used this in the past. I must have had the cat thing in the back of my head. It's because we're going to talk about cats here. Objects, they're manifested as template code. You can think of objects as templates. Classes. Classes as templates. They're called classes. They represent real world objects and they encapsulate, that's a programming term, the properties of that object. For example, for a cat class, you might have some actions. So there we are. Purr, sleep, eat. A cat has to, has some actions that it does. And after defining this object, we can copy and paste it and use it multiple instances. Maybe I have a cat. Maybe Missy has a cat. Maybe I'll call someone out on the phone. Maybe John has a cat. So we can create John's cat and my cat. And then we can.
I do have a cat.
What's the cat's name, John?
His name is Artemis.
Oh, that's a great name. All right, we're gonna make Artemis. So we can set the various attributes of the class. So my cat name equals Tom. So what does this look like? In Python, when we're going to make John's cat, when we're going to make Artemis, that's called initialization. When you're taking that, copying and pasting that action of using the template and then making an instance of it, that's called initializing instances. So first we need to create a class before we can initialize an instance. And so we're going to make a class my class, and then we need to make something called an attribute. So this is my attribute. And this is initialization of that instance. So this is how you would make that new class object. So if this would be John's cat, this would be Artemis, for example, equals my cat classes. Maybe I have cats down here somewhere. I think I do. I got person, I don't know. They should be down here. But anyways, so then we can call type on my class instance. And we can see that it's an instance of my class, which is just something I totally made up here, right? So I could name this anything. I could name this, and then I could change it. Well, it has to be the same. So there we go. Type my class instance. There we go. So now it's of type ADFA. So you can name it whatever you want. In this case was my class. And then you can call your attributes. So we created this attribute of this class called I'm a class attribute. So to access that, all we call is my class.myAttribute. So it's my class, the name of the class, .myAttribute. So you'll see that a lot throughout Python where we're calling like class.attribute. And you can change this attribute sometimes. In this case, you can change this attribute. So we can call my class.myAttribute, and we can assign a new value to it. And we can say, now I've changed the class attribute. The power here, remember I said copy and paste? Well, normally if I wanted to make a class with that attribute, I'd have to make it a bunch of times. But here, I can just make a whole bunch of different instances. So I made 3 instances of my class. Called them instance 1, 2, and 3. And then I reassign their values of attributes to be 1, 2, and 3 here. And then I printed those and you can see them. I don't know if I want to get into constructors and inits, but basically when you create a class for the first time, there's something called an init function or an initialization function that says, okay, when you make this for the first time, when we make a cat for the first time, what do we have to set up to make sure that a cat represents a cat? And maybe there's variables that need initialized or instantiated. I won't go through too much of this. Let me just show you maybe what. Here's an example I wrote. The whole point of classes is that they can interact with each other. So this is a person and a coffee class. So I made a person class that has 2 attributes. A person has to have a name, and you have to pass that name to the initialization function. When we make a person for the first time, they need a name. And when a person exists for the first time, they have no caffeine. Originally, they start with no caffeine. That's when you first create them. So down here, we create a person. Nivens, Alice in Wonderland, we make the rabbit. And so we make Nivens, and this is the name that we're passing. So this name matches here. Self always has to be here. So I know I said order matters, and you're probably like, well, there's 2 here and there's 1 here, so that doesn't make any sense. Self is always here, and just pretend like it doesn't exist. It is. And so we're going to pass Nivens, and that gets passed a name, and so that creates a person named Nivens. And then we're going to create Alice. They're going to enter a coffee shop, and they're going to order a coffee. So my latte, and now I'm going to create a coffee. Coffees start with 8 ounces. When you initialize them for the first time, every coffee has 8 ounces. And now I want to say I print out the amount of coffee in my latte. So I print that out. So you can see there's 8 ounces. And then here's my coworker's coffee, and it has 8 ounces. And then mylatte.drink.u. So this is where object-oriented programming gets complicated. But I'm calling the object mylatte, which is an instance of coffee, which at the first time that I create it has 8 ounces. And then I'm calling the function drink, which is this function, which takes in a person. So it's taking in you, which we define you as this person named Nivens. And Nivens is this name and has 0 caffeine. Whew, that was quite a bit. Oh my gosh. So when mylatte.drink, you, Nivens, when we call drink, it takes in this value person, and it calls person.caffeine, and it plus equals 5 to it. So it calls this attribute caffeine. So Nivens started with 0. Now we just added 15, what would it be, milligram? I didn't add any metrics here. 15 increments of caffeine to Nivens, to person, which is Nivens. Self.ounces now reduces by 2. We reduce it, we took a sip, so we reduced the number of ounces that we drank of the coffee by 2. You don't have to know any of this. Don't retain any of this information. I just want to point out this is the way object-oriented programming works. So when we talk about coffees interacting with persons, when we talk about data and models interacting together, just maybe keep in mind this is how this works. We have functions that take in other objects. They do things to them. They pass data back and forth. That's object-oriented programming. I won't go through all this. Yeah, please.
So I noticed in a lot of your coding, you have an F. So print, parenthesis F, and then in quotations or single quotations. But the F doesn't show up because probably it's outside of the quotations.
That's actually a really good question. So there's about 50 billion ways to print in Python. That's one of the bad things about Python is there's no like one good way to do things. Add some more
We do
people.
without the F or without.
So yes, we can do print this, and that prints fine. And we can do print this, and that prints fine. And we can do print the single quotes too, and that will print fine. What the F does is if we want to use a variable, my variable equals really cool. So we can do print F, this is, and then we can do my variable. Oh, sorry, I forgot to. Python tried to help me by adding that extra one there. Did you see that? There we go. Okay. So this is really cool.
This is plus my variable.
Yep, that's another way to do it.
Oh,
Let's do it that way. So I know this is one of the gripes with Python is there's about 50 different ways, not truly 50, but there really probably is at least 4 different ways that you can do this. Oh, sorry, that's my bad. This is not a string. This is a variable. There we are. Oh, yes. So you can't put the, you don't need the curly braces anymore. So I would have to put a space there. There we are. So this is really cool. But between the two of these, so let me show print without the F. This is, and then let me just copy this up here. See how this didn't work. So this says this is my variable because it truly believes that these curly braces and this word my variable is a string. We've done nothing to tell it otherwise. In this case, when you use F stands for format, print.format. It interprets any time it sees a curly brace, it says, oh, whatever's in there is code. So you can put as much, you don't even have to put a variable in there. You can put like 1 + 2 + times 7. It just reads that as code. So it's like anything inside a curly brace is a piece of code. And typically people use it to print variables. But yeah, you can add things together too. But I think this one's a little more readable, so I'm a little biased towards it.
So, and then I know it's getting over it, but the F is one of so many. So is there another one that you use on a daily basis that also is a benefit to know about?
I would say just regular print. I definitely use that on a daily basis. There's one more. There's the original print.format. So print this, I have to remember the syntax here, I'll just do 1, 2. 1, 2. Sorry. Looking at that and, okay, format my variable to, why is that not? I think that should work. No. I have to remember this, but there's print.format. There is a Python how to print only 2 decimal places. This is what I'm trying to get to. I've used this before. So sometimes you'll be working with floats. You'll get an output from a model, and it'll be like, oh, your performance is 87.67539, and like your stakeholders don't care about that. So they're like, round it, please. And so there are ways you can do round, but you can also just, here it is. This is what I was looking for. Because it's on the string, not the print function. That's what I was doing wrong. I apologize. So, so it's on the string. So format is, I'll show you what I was doing wrong here. Format is a function of a string object in Python, where I was trying to make it a function of a print function, which it's not. So function of a string object. So this I have used. What it will do is if I have, let me make a float, my float is equal to 1 point, can't put a U in there. There we go. Okay. And we want to print my float. This is probably the worst formatted syntax I have a biggest gripe with in Python, because what the heck does that mean? So this, I don't know who came up with this, and I hope they refactor this in the future, but what it means is everything on the other side of the 0, so everything on this side of the decimal point. So you need the colon, you need the dot, and then the 2 tells you how many decimal points, and then F for the floating number. So this would be like if I wanted 6 decimal point floating numbers, then I could have 6. You can also use the round function. Note this will like literally cut off. It does not round. So this goes 4, 4. So just be cautious. You know, this 0, 4, 4. Oh, it did round.
Yeah.
It did round. That actually very much surprises me. Oh, that's cool. Okay, so we learn something new every day. So it does round, I guess, but I do use this sometimes to print when I want to like limit to 2 decimal places usually. That's pretty much the extent of printing. Let me think, what else? Any other questions on printing? Okay, we'll continue. Let's see. I think we were going to take a break after this. I think we're done with functions. Right, we're going to do our breakout activity. I will give us, maybe let's start 10 minutes. We'll take a break. We'll come back to another 10 minutes of our breakout activity. So for our breakout today, I have to check. I have to remember what I had for us. Yes, we're talking about functions, and then after functions, we'll come back to libraries. So if you guys could grab this link here, I'm going to drop it. Here's our breakout. Spend 10 minutes on this. You just click download here, or you can clone my whole repo if you're familiar with Git. But for now, you just hit download there, and then wherever you're doing your Jupyter work, you can just drag. Oh, sorry, you have to drag into the. I apologize. You have to drag into this actual space here, and then you can just click upload. So here's the breakout activity. You're just going to work on some functions and getting familiar with them. Feel free to work with each other on this. So for this first part, you're performing text analysis for different authors, and you decide to write some functions to assign some scores to words. And so the first word is called doubly, and it should take in a word and return the number of repeated letters. So in this example, doubly takes in the word beer, and it returns how many repeated letters there are. So 2. It would return 2 in this case. Oh. Let's just start with doubly. We can get to vowel density later. I think this has some of my code in it, so I guess you guys got a head start in there. Because it says my test word. That's funny. All right, give you a little head start. Did I fill in? Oh no, good. Okay, good. Maybe it doesn't. Maybe that's just supposed to be there. Give you guys 10 minutes on that. Are any of you Anna? Oh, good. You were able to get in. Okay, I'm sorry. I just saw your message.
I'm standing outside for 2 hours.
I got really worried.
The guy was there too, right next to the door. He was looking for
Yeah.
Just like a dog.
Are you on? He was like, sorry, I was yeah.
Why is the door locked? If they're classes?
Yeah.
I don't know. We're supposed to have this app on our phone that I'm supposed to be able to use to geo key. It's supposed to let us in, but it doesn't work. So.
Adam doesn't know across the street until library.
So there's a function in Python called in. I didn't talk about that, but it does exactly what it sounds like. It sees if something is in something. So in here we have my test word. We're assigning the word beer to my test word. We're saying if 2 consecutive E's are next to each other within my test word. And it's saying, yes, they are. EE is in beer.
That's out there. I was like. Oh, yeah.
Is there a function or not function, something that like looks for repeated values?
That's a good question. Not off the top of my head. Check. Huh. Oh, in data frames, which is not what we're working with. Well, we're going to get there at the end of the day today. Duplicated can check for duplicates, but let's be specific here. Python function for strings to check for repeated characters. There you go. How to detect duplicate characters in a string. I don't think you want to do that. That's really complicated. But you could.
Most characters and bonuses and that's right. This is normalized.
No, would be my answer. I think those are all manual ways. Let's
So
see.
if you run it, it says that W is not, because I just ran it just to see what it says. And then it says name W is not defined. So we have to define something.
Oh, yes. Yeah, because we need to.
Let's start with just the repeated vowels. I'm realizing.
I'm there, I'm not there.
I can define my function. That's it.
Let's start with just repeated vowels, by the way. I think in here, I think I misspoke. I think I said repeated letters. That's really complicated. Vowels, we just do repeated vowels in the word. And don't worry about this third one. Oh wait, unless we use that later.
It has to equal something, right? Yeah, because it's a function.
is a function first. So,
Okay, so W instead of
Is there a plus plus syntax in Python?
There is. It's going to be plus equals. So your val counter would be plus equals. You have to do plus equals 1. It's not quite as pretty as like Java with the plus plus.
Okay. Thank you.
You're welcome. Trying to think of how to do this too.
okay, I'm so bad at it, like totally lost.
And I've done this before, so that's terrible. So I put a val counter here. So I'm going to count the number of vowels. At first, I think in some old code, if vowels in char. Well, there's a couple different strategies we could do. We could either try, I'll just walk you through one. We could try doing for vowel set in vowel doubles. We could say if vowel set is in chars, then we would do vowel counter plus equals 1. But we're going to run into a problem here. So basically this is saying chars is beer in this case. So we're passing beer to doubly. So chars is beer. So in our example, we'll set vowel counter equal to 0 just at the initial beginning of this function. And then we're going to say, hey, we're looking for pairs of either AA, EE, II, OO, or UU. These are our vowel doubles. And then we can say we're creating a new variable called vowel set and out of vowel doubles. So you can do this in for loops. Basically, you can say for, you can make a new variable name, and you can say in, and you can pass it something that's iteratable. In Python, that just means something you can iterate over. A list is iterable. So you can pass it a list, and what this is going to do is the first pass through, it's going to be equal to the first item in the list. Vowel set is going to be equal to the first item. A lot of times people might call this X. The second time through, it's going to be EE, II, OU, OO, then it'll be UU. So I called it vowel set. So we could say if vowel set is in chars, for each time we loop over this list, it'll say if AA is in beer, if EE is in beer, if II is in beer. So each loop, it'll loop 1, 2, 3, 4, 5 times. So the first loop is AA, second loop is EE. But if AA is in beer, then add 1 to our counter. So if we had a word that had a bunch of sets, we could do that. What do you guys think is the problem with doing it that way?
So, does it end after it's done with beer?
It would end after it's done with beer, and we'd have our vowel counter.
Is it that it's going to have to take each instance? Okay.
What do you mean by that?
Because like it has to look at AA and then it has to look at EE until it matches.
It will have to go, that's a good point. It will have to go through each instance and look at it.
So like if this was a longer process, it would just take too long.
That's true. We would quickly get into like an unsearchable space if we wanted to do this a lot. I think the issue that I'm seeing, and maybe I'm wrong, but if we had a word like amazing, we have 2 sets of A's in here. I don't think it's going to account for that because it says for vowel set, if vowel set is in chars. So if AA is in chars, it's going to say, well, yeah, I found an AA, and then it says vowel counter plus equal 1. But it's not counting that it found 2 sets of AAs. So I think it's just saying A double does exist, but it's not accounting for all of them.
So it would just return, in a sense, like a one.
Yes, I think so. We can test it here. Let's try her out. Error valve is not defined. Oh, spelled it wrong. I can't type. Below. I don't even know how to pronounce that. There we are. I didn't define vowel density yet. That's fine. That's something else. There we go. In this case, oh, what did I not do? What did I not do? Why did it return none?
Did you run?
I
You
did
didn't
run
return
it.
a value.
I didn't return a value.
Oh.
So we need to return val counter. Otherwise, we talked about scope. This variable val counter only exists within our local scope. It's a local variable. It quite literally gets erased after this is done. So we need to return what we found from that. So this isn't returning val counter, but it's returning the contents of val counter. It's returning the number that we're assigning to it. All right. So you were right. It just did one instead of two. Okay. Keep working. Maybe another, what did I say? We take a break and then I don't want us to run out of time. I still want to get to. We'll take a 10-minute break and then we'll come back. I'll see if I can dig up my answer for this and I'll share it. And then I'll let you guys, I'll leave part B to you guys if you're interested, and the rest of A. And then I'll share the full answer by the end of the week. We're going to take a 10-minute break here, and when we get back, we're going to talk about libraries, because that's all we're going to do in this class. The nice thing is, like, somebody else that's much smarter than me on the internet made a bunch of libraries that we're going to use. So we're going to talk about libraries. We're going to use NumPy, Pandas, Matplotlib, TensorFlow, SciPy, all this good stuff. And then we'll talk about the standard library packages, some Pandas documentation. Oh yeah, we want to get into Pandas. So yes, we're definitely going to take a break and get back in bed. So 10 minutes, 8:19. Feel free to continue your break, but I'm just answering a question here, if you guys are around, which is, asking about functions and if we have to define the function before we call it. And the short answer is yes. The long answer is sometimes you can get away with. So in this case, we're going to run doubly up here, and then we're going to rerun the function. The thing is, the reason we can do that is because we're working in this notebook. You see it says 12, 11, 12 here. That's the order that we sent this to the interpreter. But if we do something called restarting, it means we're clearing everything out. That's what restart does. We're restarting the kernel. That means all of our variables are wiped. They don't exist anymore. And we're going to rerun this. And you see that if we try to run top to down order and we try to call doubly before we've run this def function, we're going to get this error. Name doubly is not defined. So we have to run this first and then run this, correct? It's a good question. All right. So I wanted to share this with you. I'll drop the link. This company, I haven't looked at their Python one specifically, but I've used many of their other cheat sheets, and I've found them to be really useful in the past. So this is DataCamp. I've used nothing else from them other than their cheat sheets. So I can't speak well for any of their courses. They're mainly like, they have like DataCamp courses, data courses, but I've used their cheat sheets and I found them to be very well organized. So I assume, I'm making an assumption that this is the same for the Python one. But yeah, so they'll have like, here's how you import a package, working directory, here's some operators and functions. So it's sort of a high level summary of everything we've talked about. So I just wanted to give you guys the answer here, or a answer, it's not the answer. Programming is one of those things where there's about 10 million ways that you could do this. This is one approach. This is how I had solved this. So you actually have to make quite a few functions, I think. But for the first part, we were talking about just for doubly, take in a word and return a number of repeated letters in the word. So we're taking a word. In here, I'm setting a variable called previous letter. So the first time we come into that function, it gets set to none. The number of repeated letters gets reset to the value 0. You think of this like you're playing a pinball machine. We're resetting everything to the initial values. You know, you've got 3 balls now in the beginning and you have no points. So that's what I'm doing here in this first part, is just resetting. And then we're saying 4-letter in word. So that's one of the elements of a for loop. You can iterate over things. And letter is just a number, a variable that I made up. I could call this X for X in word. I could call it whatever I want. Word is this. This is the parameter that I'm taking in. So it's basically saying for every positional element in the variable word, if previous letter is equal to letter. So let's take in the word beer. If previous letter is equal to letter, well, the first time we get here, previous letter is equal to none. Previous letter does not equal B, so we move on. Then previous letter is now equal to letter. So previous letter is B, so now previous letter is now equal to letter. This is one of those situations in programming where like just looking at the code and walking through this verbally is not very useful. So maybe if you're interested, I would recommend kind of writing it out on a piece of paper, what each variable is for each loop. That's a pretty standard way of doing this. But the second time through this loop, previous letter is now equal to B. Let's go to the third time. The third time through this loop, previous letter is now equal to E, and current letter is equal to E. And this is a situation where this is going to be true. E is equal to E. Previous letter is equal to current letter. And then we decide that the number of repeated letters plus equals 1. And then we return number of repeated letters. So that's the solution. That was a little complicated. Apologize.
Are we like expected to be on this level?
No,
Okay.
just get new brains churning here. We're going to get to what we're actually going to do, and you guys are going to be like, why did you put me through that? Stress for no reason. That's my hope, at least. But occasionally it's useful when you're debugging things. So let's jump and talk about, make sure I'm on track here with my agenda. Just want to make sure I'm not forgetting anything. We covered data structures. We're going to talk about libraries here, and then I do want to get to pandas. I didn't move very fast this class, so I apologize. So we'll spend most of the time here. I'm going to give a 10-second look at libraries. Libraries are basically somebody wrote a bunch of code and they organized it in a really logical way, and then they stored it into a structure that makes it so that we can import that and use it. So anytime you import something, that's actually a library. So I don't have any imports in here. Did we import? I have no examples of importing anything, so I will just have to do that right now. We're just going to import something. We're going to import math. There's a package called math. So we're going to import math, and now we can use the math package. We can use math dot There we go. We can take the cosine of something or the sine of something or the ceiling. Trying to find something more close to home. Yeah. Is infinity, we can tell something, but log 2. So you can see that these are all, here, remainder. Let's see. I don't know how that function works, actually. I'd have to look it up. But anyway, so there's a bunch of math functions. You get the idea here. They're really useful. So this is a package. The math function is a package. It's a library that we're importing. There are two kinds of libraries. There's the Python standard library. Math is a Python standard library. So sometimes when you're in classes, they'll say, develop this, but only use the Python standard library. That just means things that are developed to be native in the Python language. Math is part of the Python standard library. You don't really need to know the difference, but just know that there are two. There's that, and then there's PyPy. So PyPy it's PyPI, PyPy. This is the Python package index, and this has a whole bunch of packages. I can develop a package and put it on PyPy. Anybody can develop a package to put it on PyPy. So that's the difference. The Python standard library is like the really basic packages that exist come native with Python. When you pip install Python, it comes with those packages. The PyPy library, you have to install these separately. So when we say pip install, pip is just how you install a package. I probably should mention that. Did you guys learn about pip?
Yeah.
Oh, good. Oh, good. It's pip. Sometimes you have to use pip3 if you're, but if we do pip install sklearn, for example, that's going to be a package that is in PyPy. This is a package that you're going to have to actually install yourself. See, I already have it, so it says your requirements are met. But there are, here you go, 500,000 projects. What?
How would you know, like, oh, I need to use a terminal to, like, input that rather than import it?
That's a good question.
Gotcha.
No, you did get me. This gets to environment management, which I want to talk about in Module 9. Okay. So you're ahead of the game here. You're way ahead. But for now, if you try to import something, let me just look up a project and try to. I'm trying to think of something I don't have installed, and it's actually quite hard. If you try to import something and it gives you an error like that function doesn't exist or that package doesn't exist, just message me and I'll let you know. But you'll probably have to install that package. So we talk about sklearn. Pandas is a great example. How about this? Everybody try this. Here's a great way to answer your question. Good transition. From Pandas, import PD. Can everybody run this? Oh, look, I got an error. I'm so happy. Here's what it looks like when you don't have the Pandas package installed. There we go. Cannot import name PD. Oh, from Pandas. Oh, I'm sorry. I'm tired. I apologize. Do import Pandas as PD. Nope. That is not what it looks like when you don't have Pandas installed because I have it installed. Or just do import Pandas. Here we are. Does import Pandas work for everybody?
Yes.
All right, friends on the phone, does import Pandas work for you?
Yes.
Yes.
Yep.
Perfect. You'll notice, by the way, if you guys go out and read documentation about Pandas, a lot of people will say as PD. That's just a naming convention. You can call it whatever you want. I can call my Pandas package this if I want. It literally doesn't matter. But if you want to be kind of like standard convention, you'll call it PD. And all that means is when you're calling the functions, apologize. When you're calling the functions of Panda, you can do PD dot and then call your Pandas function after that. PD.concat, PD. Again, I'll get into what Pandas is here in just 2 seconds. So that's all that means. If you don't put in the as PD, you can still use it. You're just going to call it Pandas instead of PD. So just a naming convention. Just makes it easier. You'll see it in other things. You might see import sklearn as sk, or you might see import numpy as np. we'll get to those packages, but that's pretty standard. All right, that's a 5-second view. I dropped these links in there. You can go check this out. It'll talk about the Python standard library and some other libraries. Let's close this. Let's get into pandas. So again, my goal is to just totally expose you to the documentation because that's where you're going to go. That and the cheat sheets. So I have a pandas cheat sheet for you here as well. And this is going to have all the pandas operations, but what the heck is pandas is a very natural question to have right now. So pandas is a Python package, and it's really their way of making Python look like Excel as much as they possibly could. They really realized that people like those tabular forms. They like to view things in rows and columns. They don't want to see things as code. This is going to be your friend. If you really like that type of view, which I do personally, this is going to be the way that you do that. So it shows the data in a tabular format, and it has different like functions that you can use. So you know how like Excel has all those functions you can put in the formula bar and do things? We have that too, but better, I promise. So it's pretty cool. There are 2 primary data structures in something called the data frame. First of all, let's just look at what a data frame looks like. Pandas, iris, dataset. Let's load in this iris dataset. Fun fact, this is part of your homework assignment. So, so we're going to load in this iris dataset from this package called sklearn scikit-learn. What's cool is I just Googled pandas iris dataset, and I clicked on this sklearn link. And then if you scroll, ignore most of this, we'll go through this later. But if you scroll to the bottom, they have like example code down here. So you just copy this. We're just going to, we're going to put it in our class notes here. We will have to import sklearn, but I think that's in here. Sometimes when you read example code online, they're going to have these little carets or greater than signs. Sometimes they're called carets. You will have to delete those when you put this in your, that's not going to run with that. They're just showing you what the difference is between output and input to code. So that was an output one because it didn't have any carets. So I have to delete this. Okay, so, sorry, let me do this not so fast. There we go. So we're going to do from sklearn dot datasets, we're going to import load iris. So this is the way that packages work. Packages are basically, you've got a directory with a bunch of files in it, and then a bunch of subdirectories. So what's really cool about sklearn, you can go to the source code. So all this is doing is it's saying from sklearn, and it's saying, okay, here's sklearn datasets. So when you hit sklearn dot, you'll get all these options. So they're just folders. That's all they are. They're just folders with different, more folders and more code in them. So dot datasets goes to here. So you can see we're in sklearn dot datasets, which is exactly what we put into our code here, sklearn dot datasets, and then we import load iris. So then we're importing this, we're importing something from in here. I won't get into that, sorry. We're gonna load iris. We're gonna call their load iris function, which this isn't necessarily the normal way that we load data, but sklearn conveniently created us a function that loads the iris dataset. And so what we can do is now we can do type on our data. Let's check out, what is it? It is a sklearn utils. We want this to be a data frame. Let me see what's in here. Okay, it's a array. So I wonder if we can just, so in Pandas, we're gonna go PD data frame.
Sorry, could you mute, please?
See if I can do. And there we go. Got it. So now we can do pd.dataframe.
Okay.
Or is it supposed to be the same line? Okay, I'm not super familiar with the structure of this yet, so.
So which part do you have to run first?
Oh, sorry. I was trying to show you what a data frame looks like, so I'll come back to this, okay? This is, because this is not, but you would have to run this first. This from sklearn datasets. Let me delete all this unnecessary code here. Iris data set here. Here we go. Load Iris. Let's get rid of this code. Okay. All right. Let's see. So we have, so we loaded this Iris data set in, and this data is probably not in the format that we want it to be in, and we want to try to get it into a data frame, an array.
I had to mess around with this earlier today when I didn't know what we had gone over in our class on Monday, so thought I was behind.
Oh, good for you.
I had to say pd.dataframe and then data equals data.data and columns equals data.feature names. I put it in the comment.
Gotcha, that's helpful. Okay, so this, remember when I said dictionaries will come back to haunt us? This is the dictionaries coming back to haunt us. So I see what they're doing now. So this is actually a dictionary. They've stored their data into two values, key values. One key is data, and the value associated with that is an array of all of the X features, all of the input features. And their second key is target, and they've stored all of the rest of their data into this array. So thank you. Was that John? Thank you, John. I think it was John. It was perfect. So data.data, thank you. So data.data is going to have all of our data features. So we're going to do PD because we called our pandas package PD. We did import pandas as PD. So we're going to do PD.dataframe. The D and the F have to be capitalized. And we're going to do data.data. Remember when I talked about you can either pass variables just in the expected order, or you can specifically define the parameter you want to assign them to? This is where that type of stuff gets important. This is why we talked about all that. You can specifically assign this to the data parameter if you want. So we can do data equals data.data. So that's what John was saying, data equals data.data. So this is our X variables. All right, so now I said this is an Excel format. So this is what a pandas data frame is. When we say pandas, this is what it is. See how pretty that is? See how much prettier that is than what was it before? It was data.data. That's hard to read and like hard to work with and hard to understand. So we can make a data frame instead, and then we get all these cool functions with it too, like .head, which means print the first 5 rows. Or maybe I want you to print the first 10 rows. You can pass it a parameter, the number of rows you want it to print. Default is 5. If you pass no parameters, it'll print 5. So this is our data frame. Notice the columns say 1, 2, 3, 4. So we're probably going to have to logically name those. So we're going to come back to that. I just wanted to show you, thank you, John, what a pandas data frame was first before we actually dove into it.
Didn't do 11 because there's the 0.
Yep, that's correct. So that's when we talk about tabular data, that's what it is. Data frames have 2 structures. There's 2 primary structures within pandas. There's something called a series, and then there's something called a data frame. So we just looked at a data frame, but data frames are made of an object called a series. And these are just objects. They're just the same order as an int or a string or cats or any of those other things, any of those other classes that we talked about. But these are different types of objects than Python natively has. These are data frames in series. And there's a good picture on here of what the heck a series is. So this is the Pandas data representation that considers this a column. So the nice thing about Pandas is they talk in columns and rows, which I think is natural to all of us. This is considered a row. And then when we get down to a series, this is a series. So the value tags, the indexes, the 0, 1, 2, 3, 4, and the column values associated with that. So our index and our column values. So a series is basically a column slice, but it also has the indexes associated with it. So that's what a series is. You'll get a lot these NaN, N-A-N, not number. That's what that stands for. Value represented in NumPy. They use that just to be confusing and not use the none attribute. So this is another way of representing null values. You'll see NaN. But there's a bunch of stuff you can do in here. I'll leave this to you guys to maybe assignment to read some of this. But here's the description of the two data structures. We have a 1D array or our kind of 2D data frame that looks sort of like an Excel sheet. Here they talk about why there's more than one. This is very important. All Pandas data structures are like value mutable, sorry. So the values that they contain can be altered, but they're not always size mutable. And data frames sometimes can be created in place, but a lot of times you're going to have to assign them back. So when I made this data frame over here, I made a data frame in the sense that it ran in memory and it printed output, but it's not actually assigned to anything. So we can't actually do anything with it. So we're going to have to assign it to my training data or something, or just training data. We don't have to put my behind everything. Training data. So there we are. So now we have a training, or at least a data. Oh, I just overwrote that variable. So that's something you can do in Python, by the way. You can make a new variable called data, and I assigned my Pandas data frame to this. But notice what happens here when I try to call data.data. It says, oh no, there's no attribute named data because data.data is no longer this data that I loaded from Iris. I did something called overwriting a variable name. So I have to rerun. I reran this cell, and then I reran this one to reload in my data, rewrite that variable, and I'm going to call this data frame. Or actually, I'll be conventional. A convention is to use df to represent your data frames. That's pretty standard. You'll see that a lot. Okay, so in Pandas, this is how we import Pandas. We talked about that. There's about a billion ways. This is one of those things. There's about a billion ways to create a Pandas data frame. So we created that data frame by reading the Iris data set, and we called pd.dataframe, and we passed that data to that attribute. But another way you could do it is you just manually create it. So they're passing in a dictionary. So you can pass in a dictionary, you can pass in a list, you can pass in an array, you can pass in a series, you can pass in a bunch of different objects to create this data frame. So in this case, they're passing in this array here, and they're saying name, and here's some names, and they're saying age, and they're saying sex, and then you get this as the output. So that's Pandas data frame. And this is what it would look like kind of in that Excel representation. We talked about that. So df at age is a series, for example. So df at that column slice, that is now a series. So if you're ever working with a package and it says expected series received data frame, it's probably expecting a column and you passed it all of your data. Or expecting data frame received series, you passed it a column. You have to send it the entire data set. Okay, that's fine. Let's see what else. All right, so this is, now there's a bunch of operations. So they're doing an operation, this max operation on their age column. Df at age equals max. So this is how we, let's go back to our pandas. Let's go back to our iris data set and let's add some column names. How about that? And then we're gonna try to select and slice things. Where did my sklearn? I have to look that up again. All right, let's see if we can figure out what the column names are here. Did you figure that out yet, John? Oh, target name. Oh no, that's,
Feature names.
yeah, the feature names.
I just did data.feature names. I said columns equal data.feature names.
Sweet. All right, you're doing my teaching for me. Thank you. Appreciate it. Let's see, data.feature names. Okay, so there we go. Here is our feature name. So this is sepal width, which these are flowers. You guys are gonna classification of flowers. That's part of your homework. You're gonna figure that out. Sepal length, sepal width, petal length, petal width. So we're seeing if we can take different measurements of a flower and basically classify them. I think they're a flower. Correct me if I'm wrong. I could be misspeaking. So what we're going to do is these are a list. This is a list of values. We have 4 items in this list, and that matches the number of columns that we have here. So we know that because these comes in sets of 4. So if this was a customer, for example, this might be row 1, row 2, and each of these would be column values. So we want to assign these column values to our pandas array, pandas data frame, so it doesn't look so ugly. Or, oh, why did that not print? Oh, because I assigned that to a value. Now I have to print it. We'll do this instead, actually. There we are. That's a more natural way to use that. So we're going to take these feature names and we're going to do column equals. Columns, I think it's columns. Yeah. Now we have column names, and it was that easy. So now we have some column names here. This one over here is just our index. This is just keeping track of the rows in the order of them. Sometimes you might want to shuffle your index for various reasons, so it just helps us keep track of the order. So this is our sepal length, sepal width, petal length, and petal width here. So these are, in machine learning, we'll call these our X variables. Sometimes they're called our features. As you can tell, they actually called that here, our feature names. Sometimes they're called variables. Those are pretty much most of the names. So now we have our data in here, and maybe we want to make our target. In machine learning, what you're trying to predict is typically called your target. So they call this data.target. Let's make another one. Let's call this df features. And let's call this df features.head. And let's call this df target. And instead of passing data.data, we're going to pass data.target names, and we're not going to give that a column name. So df target head. All right, there we are. Oh, those are just the names. I'll have to figure out what did they just call it target. There we are. df.target. So here's our target. So you're going to notice that in here, I see why they gave us the name. Our targets are all 0s and 1s. So and 2s. We can do, there's actually a function in here called, now I can start to just really, I'm just going to show you a bunch of random pandas functions. You can do df target.value counts, and I always get the syntax wrong here. There we are. The value counts will tell you basically the distribution of your data. Wow, this is really like beautifully distributed data. This is odd. There are 50 representations of 0, just like we see here. There are 50 representations with 1 and there are 50 representations with 2. So we can do it value counts on another one. We can do DF. Let's do sepal length centimeters. It's weird. This column name has spaces and stuff in it. Yeah, there's usually a reason why we don't do that. So I'm going to change our column names here. Don't put spaces in your column names. Make your life harder. New call names equals this, and we're just going to get rid of. And we're going to put underscores. Make your life easier here. I will send this out too. Now that I realize I'm putting a bunch of stuff in here. Okay, so, okay, there we are. So now we have underscores. These are just easier to use. Now when we try to actually do operations on them, spaces have meaning in programming languages, so you're just going to want to avoid that. df at, so that was our df features data frame. This code book is getting out of control. Sorry. df features. So if we want to grab a column, we have all these features here. We want to grab one column. We use these square brackets. That's the syntax for that. And you put in the column name, but the column name has to be a string. So you put in the column name as a string, and that's how you know which one you're going to grab. So we want to grab sepal length. Oh my gosh, it's going to be hard to say. Sepal width. Here, we can grab that one. Now, if we want to look at what are all the different types of values we can do for that, value counts. We can look at, so it'll tell us there's 26 rows with 3, there's 14 rows with 2.8, there's 13 rows with 3.2. You can see how value counts is maybe a little more useful when you have like categorical variables. If you have numerical variables like this that are scalar, meaning they can exist between 3 and 1, between 2 and 1, there's maybe a different way to view that. But let's get to this. Let me see, what else do I want to tell you about pandas? Oh, this function is super useful. This is df.describe. This will just describe your whole data frame to you, which is pretty cool. Whenever they say df in the documentation, they just mean whatever df you're working with. So I'm going to change this to be df features. There. It'll give me how many, the count, so how many records are there, what's the mean, what's the standard deviation, what's the minimum, what's the upper or lower 25%, what's the midpoint, the 50%, what's the upper 75%, and what's the maximum value. So if you're just like, need a quick second glance at your data, that's super easy. Excel doesn't do that, does it? Huh? Yeah, yeah, I'm gonna convince you guys.
Would it do linear regression?
Would the Pandas itself?
Yeah.
That's a good question. Pandas doesn't do linear regression, but sklearn does. And sklearn takes in a Pandas data frame, so they're friends. Here we are. We're getting to this next week, but if we want to jump ahead, here's
No,
our
it's fine.
model. No, here we are. We can do it. You want to do linear regression? Here we go, guys. We're going to linear regress on this data set. Show you how easy this is. I bet I can do it in 7 minutes. I just have to make sure we have, so we've already got NumPy, but I do have to import linear regression. We didn't have that as well. We're going to use the X features that we created, so we don't need this. We don't need that. All that was doing is it was just showing the formula for the linear regression, which we talked about last time, fun fact. But we do need this regression model. Don't worry about this. We'll get to this stuff later. But we're going to make a regression model, and then We're going to do fit, and we're going to pass it our features as our X variable and our target as our Y. There you go. We made a linear regression. Here we are. We made predictions. So
Awesome.
we'll get there. But let's see. I could even score it. Here we go. Well, this isn't going to make sense, just so you know, because I'm training on all the data, and I'm scoring on all the data. So this score will be a little nonsensical here, but just for fun. There we go, 93% accuracy. We made a model and we had 93% accuracy. Later in this course, when we talk about model methodology, I'll tell you why that is a horrible way to measure your model. Okay, so pandas, let's see. Let me go back to this cheat sheet. Let's see if there's relevant things in here. We talked about data frames. Sometimes you're going to want to drop things, so you can call this drop function. Pandas has a drop. You can, whenever you see S, they're indicating what the syntax is for dropping from a series. Remember, we talked about a series is a column. So if you want to drop from a column, this is the syntax for that. If you want to drop an entire column, in this example, they're dropping the column country, you would just do drop country equals 1. So we can do this in our data set. There we are. So if we wanted to, we can drop, which column do you guys want to drop? Let's do it. We don't need you. That's what we've decided. Look, it's done. So this is the same thing as in Excel, you would right click a column and you click delete. That's what we did. We just clicked delete. Now, I think this is not in place. Maybe it is. It is not in place. So if you notice, we deleted that, but then it came back. How do we get rid of that? You either have to do one of two things. You have to reassign. So you have to assign that new, anytime you see something, here's a way to know it didn't reassign. Anytime you see it print something out, it did not reassign because it's returning you that value. If it's returning you that value, the other option to do here is something called in place. There we go. There we go. See how it didn't print that time? See how it didn't print me a data frame? That probably means it actually assigned that value. And so now if we print df features, whoop, it's gone. Okay. One thing that's I found really difficult when I started using Pandas data frames, unnaturally difficult, is how the heck do you grab like an actual row? Like I want a row, I want a person, you know. So there's this thing called loc, series df.loc. That is really useful. Let's see, I'm seeing if they have it in here. They don't, but I'll send that. I'll send that along because I found that really useful. So that's dropping. Those are less important. Over here, we have some functions. So if you want to get df.sum, if you want to get the mean, df.describe, you can also apply these same functions to a column and just get the mean of a column. Let's see. Selection, I think, is going to be where you're going to spend most of your time. So, oh, here's the loc. So if you want to do iLoc, if you want to select, you have to give the column and the row. So if I want to select, as it says here, row and column, not column and row. So I want the 0th row and the 0th column. Then, yeah. Check this out. Mostly, I think you're just going to find the most value by just playing around with it. So what's something else we want to do with this data set in the last 15 seconds? Let's do that. That's a great one. Let's create a column. We're going to make a new column. So our thing is called df. I promise this will be fast. Df features. Whenever we want to make a new column, we open these square brackets again, and we say new column. The only thing is our new column has to match the exact same length as our other columns. So I'm going to use one of our other columns. Actually, I'm just going to make it even easier. I'm going to make it exactly our other column. There we go. Now we have a new column, but as you'll see, the values actually equal that of petal length. We can also do things like petal length times 3. There we are. Now this is 3 times the value of petal length, or petal length times, maybe we run it times by another column. Petal width. Here we are. Now it's petal width times petal length. So you can start to understand how those mathematical operations can be useful here. Awesome. Thank you, guys. I'll send the links I promised. If you guys have questions, please follow up. Yeah, we'll see you Monday.
Thanks, everyone.
Bye, guys. Thank you.
Yeah.
Thank you.